Hello everyone and welcome to another video. In this one I believe we will be implementing a pool allocator, or at least the base of it. And yeah, I think we can start. I just have two notes from last episode. So I did find a better solution for this size calculation. So previously I had the if statement. Let me just bring the git changes. So previously I had this, so this was what I made during the live coding session. But there is a slightly better solution that does not need a condition, and that solution basically uses this. So we basically calculate the sum of the amount of bytes we want to allocate plus the amount of bytes one word contains, and we subtract 1 byte. And by subtracting the 1 byte, we can guarantee that the amount of words uh, that amount of words we generate after we calculate actually after dividing it by the size of a word is never going to underflow, because we basically sum the amount of bytes and we subtract 1, so this division is going to truncate it and everything is going to be fine, right? I don't know if I explained it properly, but I think you got the idea of what I'm trying to say. Alright, so another thing that I wanted to change is this function. I don't want to call it arena default. I actually want to call it make arena, because arena default kind of implies that there is a local, or actually a global object, or a singular object that is the default object, and this actually generates or gives you a new object every time you call it. So I'm going to call it make arena instead. And we can change the demo here to just call make arena as well, right? So, and this can also call make arena. And one last thing, actually, I just remembered, is that we can in fact assert here. We can in fact assert here that this, well, actually not here, but actually here inside this if statement, that there is in fact this function, right? So this is an unconditional or an invariant actually. So this is an invariant for our lib, for our library, and we can assert it, right? So we can, that's one way to make sure everything is okay. Alright, and as expected, this should just keep working without any changes, because we didn't really change the logic of the program, and as you can see, everything is perfectly fine inside the demo. Alright, so let's do a quick search. I have already a Chromium tab, and we can search for pool allocator wiki memory pool. Alright, so basically this memory pool contains fixed size blocks, and from what I understood, when someone wants to allocate something, we basically give the entire block, and when someone wants to free it, we just free the entire block as well, from what I was able to understand. Alright, so if we go to our code, we can come to our base file, base.h, and we can create a new allocator. So this allocator, I need to think a little bit about it. I'm going to just call it pool, right, for now. I can call it pool. And just as an example, we will have, for now, I need to think a little bit about this to, right, we will obviously need this header, so all allocators need the allocator header. Um, I think that for now, okay, this implementation is going to be modified in future, but now I just want a proof of concept, right? And for now, I think we can use this probably, right? We can probably use this. So yeah. So let me say this is a decal list, okay, to have to follow the standard that I'm going to explain later. I already came up with a good, or I think it's a good standard. Like so this is going to need to be placed here, right? And this is the allocator interface, right? And this is going to be the allocator allocator. So I can change the names later, right? And now I can use this declare list. I just need to change this to be like that, right? So I can use this declare list to declare so what does the Wikipedia article call it? It calls it a block. Alright, so I can say that I'm going to have a block, right? I'm going to have a block and a pool. I probably don't need to type this, to be honest, so I can simply say this, because my block is going to have a fixed size for now, so I can say block capacity, right? And the block capacity for now is going to be, I don't know, 16k or something like that. So 16 times 124, right? I can say something like this. And this is going to be data, so this is going to be my data. And I probably also want this to be word aligned, or does it really matter? I don't think it matters, to be honest, because we are always going to give the entire block to the user, so I think it doesn't matter if it is word aligned or not. But I guess we can make it word aligned. It's not really a big problem, right? So here I just need to divide that by size of uint pointer, right? So this is my block. And I think that the only thing I need now is a flag. We can import std pool, right? We can import std pool, and here I can say simply used. I don't know if I like this approach, to be honest, to be completely honest with you, because I would much rather have something else instead of a linked list for this particular case. But I guess we can use a linked list for now, just to test the concept. And in the next episode I'm actually going to implement a bucket list, and the bucket list would probably be much better, and I can replace it. I can replace this linked list when I have the generic bucket list implementation, right? So I can just implement it with a worse thing for now, and then I can implement something better later. Okay, that's fine, I guess. So we have a block has a flag called used, and it has a fixed size amount of capacity, right? And now I can simply say declare list, and this is going to be a block, and here I can call it block list, right? I can call it block list, and this is going to be my blocks. Alright, so these are my blocks. Okay, so I'm going to need the following function. I'm going to need the pool, make pool. That's just going to return me a pool, and I'm going to need, and this needs to be type theft. Right, and I'm going to need the void pool allocate, or alloc, actually I should call it alloc. So it's going to be pool, and size bytes. Okay, so I have a make pool function and I have a pool allocate. I just need to implement these functions for now, and in the next episode I'm going to implement the bucket list, and only after that I'm actually going to replace this implementation with the correct data structure that I want, right? Okay, so I think we can clean up some of this stuff, because all of these can be put in another place, probably here, right? Probably here, and I can have this struct block. Well, actually I need it to be like this, but I can actually have, so this is going to type def it for me, I guess so, right? So this is already going to be type theft. Yeah, so here I just need to do this. So it's going to be similar to the arena, actually, the public API. So I can just say block list, and this is the block list. I don't know if C allows me to redefine it, but if it doesn't, I can just use another name, it's fine. So I have make pool and pool alloc, right? So I can move them right in here. I'm going to implement make pool later, and for now, and by the way, yeah, that's correct. And for now I'm going to start implementing pool alloc. Okay, so since I'm using a list, it is probably much easier to just use the for each we implemented a few videos ago. So I can change this name to be list for each. I think for each is a better name, right? So it is explicit that we are looping through each and every one of the elements, right? Here I just need to say that, right? So we're slowly changing the names to what makes it more, what makes more sense. Alright, so here I will need to loop through all of the pool dot blocks, right? So I need to loop through all of the blocks in a list, and now I need to check something, right? So I need to check something. I just need to check if it, actually I don't need to dereference it. So if it used, then actually if it is not used, then I can return a pointer. Actually first I need to do this, right? So if it is not used, I can mark it as used, right? I can mark it as used, and I can return the pointer to it. So it's going to be it data, and I believe this is already going to convert it to a void pointer. And so if we traverse the entire list and we didn't find anything, then we just need to append another block. So I am just going to say list, and I can change the name to lowercase as well. I don't like the uppercase name, so I can say list append. It's much better. Right, this is kind of a functional macro, so we can treat it as a function, and you will see why I want to do that in probably like 10 episodes from now or something like that. So I have this, and I need to append a new block to my list, and this list appends, so this is going to allocate me already everything I need, probably. Yeah, so this allocates the size of the node, and the node already has like hard-coded the capacity. So I don't really need to pass here the second element. I don't really need to pass there the second element. So what can I do here for this? I'm thinking, what can I do that? How can I do that? Right, so well, since this does alloc and alloc doesn't zero initialize memory, I could probably just do something like this. So I could probably just pass block. Well, actually, I do in fact need to initialize it. And why do I need to initialize it? Because so I can zero initialize this, whatever, and I can say that block dot used needs to be true, right? So I do need in fact to pass an element, so I need to append this specific data to the blocks, okay, because I need to flag it as used. And this is why I don't like to use a list for the pool allocator. By the way, I've never implemented a pool allocator in my life, right? But I was already expecting this problem, because here we are going to zero initialize on the stack 16 kilobytes of memory. That's not that slow, but it's still some heavy work, right? And I don't like it. And that's why I think that the bucket list is much better, because the bucket itself is already going to have the used flag for each in every single one of the slots, right? So I think that the bucket list is a much better data structure for this, but whatever, we can improve that later. So we just appended a new block to the list, and yeah, we can just return its data, I guess. We can just return its data. Or can I? Well, in this case, I cannot really use this, right? Because this is going to be a copy. This is going to be a copy, so I need to be careful. What I need to do is pull.blocks.end. So this is going to give me the last block. And here I need the data of that, right? Oh, this is already going to be a pointer. I need the data. And what is this complaining? This is pull. Oh yeah, so this is data, then I need to say data.data. Yeah, all right, because this is going to be the block, and this is going to be the data of the block, right? So I need to be careful with this, and I don't really like this stack allocation. I really do not like this stack allocation. So we have two options, right? So I'm going to handle those two options when we have the bucket list. But here we either accept optional. We either accept an optional amount of elements or a variable amount of elements in list append, or we have some other macro that appends a new element at the end, right? That appends a new element at the end without initialization, right? So we need to have that in consideration. We need to have that in consideration, but I'm only going to handle that when we actually have the correct data structure, so I don't need to really think about that right now. But yeah, so that's something I don't like, and we need to be careful with these kind of situations. Okay, but that's fixed, so this implementation was super easy, right? Taking into account that we only support this amount of capacity. And now I need to implement make pull, and make pull is only going to basically say this is a result, and you can zero initialize the result, and in the result dot header dot alloc we are going to need a specific alloc function, so we can say void pointer pull allocator alloc, and this is going to receive an allocator, right, and the amount of bytes actually. Okay, and here we need to cast this into a pool, right, and we can simply call this function that we already have, and this is going to be the pool and sizing that. So super easy, right? Super easy. And we pass this here, and then we return the result, right? So it is properly initialized. Okay, so we need to take that into account when we have the correct data structure, but I think that's basically the pool allocator. So for now, right, for now, this is not a final implementation, this is just a proof of concept. But for now, the only difference between the arena and, where is it? The arena and the pool allocator is that the pool allocator is not going to bump, or is not going to manage regions manually. It either is used or it is not used, right? So a region is not a linear allocator itself. We just give the entire block to the user, or we append a new one and give it to the user, right? And for now, also something to change in the future. For now, the block capacity is fixed size, and it is fixed size to this amount. Okay, so I think we can probably create some tests for this, right, or demonstrations for this. So let's go to our demo file. We have our list demo, we have our arena allocator demo, optional allocator demo. We can change these names, and after the arena allocator demo we can have the pool allocator demo, right? So we're now starting to have multiple kinds of allocators. Okay, so we have a pool allocator demo. This is going to be a pool, and here I need to call make pool, right? We make a pool. Here I need to call pool alloc, and here I'm going to pass the pool. Okay, so what's going to happen here? So here we are going to allocate 3 integers, and this is a really bad test, right? So this does not demonstrate the usefulness of a pool allocator, to be honest, right? But we are going to keep it for now because we are going to change the implementation of the pool allocator, so it doesn't matter, right? but we are going to allocate 3 integers, and we are going to give to the user 16 kilobytes of memory just to allocate 3 integers. That's what we expect to happen, right? And we need to test it. So we give the user we give the user enough memory for 3 integers. That's always going to be 16 kilobytes. And I think that a good demonstration of how the pool allocator works is to have let's say, I don't know, list for each, and we are going to look through the pool.blocks, and here I'm going to say size the blocks count for now, right? And it's going to be 0, and I can simply say that. Okay, I can simply say that. So, and actually after that we can printf. I don't know why this doesn't require. Can I add a whatever? This isn't required, so whatever. So we can say after alloc 3 ints, we have this amount of blocks, right? So we have that amount of blocks, so we can print blocks count. And now we need to say the same thing everywhere else. So I don't need this. I can say, or I can simply not say void. I can just do that and discard the pointer. So after, okay, so this is probably going to, or actually, do you have enough? So an integer needs 4 bytes, right? So this is going to require 20,000 bytes. So let's reduce this to 1,000 for now. So after allocating 1,000 ints, we have that amount of blocks. Allocating another 1,000 ints. Yeah, that's correct. And here we can also pass a pool, and after allocating a single char, we are going to have that amount of blocks. So this is not a new variable. One extra char, we have that amount of blocks. Okay, so let's compile and run this demo. And this is going to complain about stuff. Let me go to the very beginning. Okay. Field blocks as incompatible type. Okay, so yeah, that's what I had my concern about a few minutes ago. So we need to use a different name inside the implementation. So what can I say? I can say that this is internal, so I can say internal block list probably. So I can simply say that the struct that says internal block list is going to be a block list, and this is going to be blocks. So this is probably going to work now in that regard. Let me check it. Right. Okay, so it's now incomplete type. Oh, I know what's going on. So I cannot define my blocks list here. I actually need to define my blocks list in here. Right? I need to actually define it in here because this declaration is to happen inside here, right? And what I need to do is actually just to make these block private. So I can simply say this is a struct of the block, and I can simply say this, right? So I can say type def struct block. we define we type def the struct block to a block. We define the block list being a list of blocks, obviously. We type def the pool, and we have the pool here, and I think this should actually already compile. Maybe it doesn't. It is complaining about other stuff. Let me just add a new line in there. Alright, so as incomplete type, and this is complaining about, oh, okay, I know what's, oh god. Alright, so I actually need to define the block as well, because we are not taking pointers, right? We are using taking the block by value, so we actually need to define all of that above, right? We need to actually define all of this in here, which is not preferable, but it's also not the end of the world, right? It's not the end of the world. So we need to define all of these like that. Okay, and I can actually type def pool, and I no longer need all of those weird things. Okay, so yeah, I think we need to move all of those declarations to the very beginning. And now does not allow extra semi. What is it complaining? So that is very strange. I don't know what this is complaining about. Oh, I know, yeah, because this, yeah, I don't need to add a semicolon there. Okay. This is an incompatible pointer because I need to cast it. Or do I? Yeah, I need to cast it, so this is going to be a pool. I need to explicitly cast this to a pool. What else? Set but not used, and that's a valid concern. That's definitely a valid concern. So we can actually fix this problem inside the macro. So one way to fix this is to just say, well, void it, and this should already fix it. Actually, I can void it after, right? I can void it after the, yeah, I knew it. I have to make some things. We can actually void it after the loop, so we don't interfere with the loop itself. Okay, so we are going to void the implicit iterator. So if we don't use the iterator, we can simply void it, and that's fine, I guess. And this should already fix that problem. Okay, so we did in fact fix the problem, and let me check that if everything is working fine. Everything, I think it's correct. We didn't change the behavior of anything. So length 2, length 2, length 3, 2500. We have 1, 2 and 3 floats. The capacity increases by 2. Okay, so now we can actually call the pool allocator demo. Okay, and we can recompile and run. And now we have the pool allocator demo. And so after allocating 3 ints, we have 1 block. After allocating another 1000 ints, we have 2 blocks. And after allocating 1 extra char, we have 3 blocks. So I think that's basically it, right, for now, for this episode. I think I don't want to go more in depth, because I've implemented a pool allocator with a data structure that I don't want to use. So I first need to implement the data structure I want to use, and only then implement the pool allocator. So basically in the next episode, I will be implementing a bucket list, right? And until then, I see you tomorrow. Thank you for watching.